Okay, great. Let's set the table here first. You see the slide here in front of you. I'll get to that in a moment. But we are at a very interesting point in graph databases right now in the world. Just got out of the Graph Connect 2015, which was hosted in San Francisco. Had about 1,000 participants. I talked to quite a few of them, actually, and a lot of them are like this. You're like, yeah, we're evaluating graph databases as a possibility for a company, which is they are scared to death of this new thing called graph databases. And so they're evaluating graph databases for their problem. I talked to a credit card company. I talked to a couple of San Francisco-based companies around social networking, talked to a company around data scientists, and they're looking at graph databases. I'm going to be presenting not from the perspective of what graph databases may be interesting for. I'm going to be presenting from the perspective of practical applications of graph databases and graph theory in industry. So this is what my presentation is going to be talking toward. And I'm going to be talking from presentations and showing you graph databases where we, as a company, actually built graph databases for our customers, where our customers actually benefited from these graph technologies. So I'm not talking to you about what is interesting about graph databases. People are interested in graph databases. That's great. What I'm going to be talking to you from is where we're actually using graph databases effectively now, and the potential of the market. You can tell I'm a little bit excited about this, maybe just a little bit behind it. We are at the forefront of this. You are at the forefront of this. I would highly recommend that you come out of this meetup and take the code that Hanlon has available for a data as a service, as a graph database, and start to play around with this stuff. Build your own graph databases about whatever problem is interesting to you, and you'll see how bloody easy this stuff is, and how amazingly amazing a graph database allows you to find new knowledge that you won't be able to find in traditional methods for solving these problems. Graph databases are not a silver bullet. I'm not selling that. I am selling my practical experience of what I've discovered by using graph databases. I've been in graph theory for 20 years now. And the change is fundamental now, because I can talk with managers about graph theory all day long, and I bore them to tears for the last 20 years. But when I show them a graph database, and I show them the relationships and the business entities involved, or the customers, or the requirements, or the whatever we're graphing, and they see it as a graph, and then they hand it to them, and they start to play with it, then we have a real paying customer who is fired up about what we just gave them. Huge difference from the last 19 years of my life, where I say we should really use graphs because they are a fundamental way of representing knowledge, and they're like, oh yeah, right, that's great, Doug, thank you. And then actually showing them a graph database that they can use to derive things that they can use, huge difference. And so that's what I'm going to be talking from the perspective of. And I'll be happy to take your questions after the end of the official meetup. Okay, graphing with goats. Why graphing with goats? Because they said, Doug, do not give a presentation with all kittens again. And I said, okay, I will not put kittens in this presentation. And goats. Goats are a very resilient animal. How are we going to scale this graph mountain with kittens? We're not. So we're using goats. Goats are fun. So that's all you need to know about goats. I will share with you at the end of this. I will share with you at the end of this thing. I use technical terms like thing. I will share with you at the end of this thing a link to this presentation so you can take it home and you can hold it close to your heart and all that. So, okay, good.
That goat looks like a kitten.
This looks like a kitten. No, Mama, oui. You know, whenever French answer a question, you say, do you think this job should be done in about 2 weeks, this contractor job? No. That's when you know you have a real problem. Okay? That's all I'm saying about the French. Thank you. My name is Doug Auclair. No relation to the French, except 100%. Okay, what's a graph? A graph is vertices connected by edges, or a set mapped to a set, or, you know, that's really kind of boring. Okay, thank you. Yeah, so here's your potential example of a graph. You have a bunch of cities, you have a map, a bunch of loading, whatever, who cares? Okay. What can we use graphs for nowadays? Well, we could use graphs for in the last century as well. It's just now that the practical applications are becoming more real. Okay, so my experience in industry. I gotta stand up and I gotta talk and I gotta move around like this. Okay, so relational DBMS, incredible advance over the technology that we had. So, been in industry like Enrique here for more than 20 years now. So, into relational DBMSs was an incredible improvement over the way we handled data management before. Incredible improvement. Hats off to them. Hadoop. I worked for a year in the stock market with FINRA, managing 6 billion rows added to our database per day. We put that into Greenplum cubed, because it was a relational databases and they were building the queries based upon multiple joins of tables. And you know that from your practical experience with big data, you know what happens after a while. When your data gets bigger and bigger and bigger, relational databases effectiveness gets smaller and smaller and smaller because the queries become more complex. With Hadoop, you have an H table, and you have keys, and you have values. And so their indexing, their gets are incredibly fast. 6 billion rows, we were able to pull out a 1 million row query in under 10 seconds. We put that to Greenplum, but because we had over a petabyte of data in our database. We put that to Greenplum. The query returned after 4 hours saying we cannot execute this query. So we changed people's lives in FINRA from moving from Greenplum, a relational database, please come sit down, to Hadoop, okay, where we're able to return our results in under 10 seconds. So hats off to Hadoop. Prop to y'all. Okay, so that's great. Hadoop's a very good solution for a very specific set of problems, and it does it incredibly well. Relational databases are a very elegant solution for a very specific set of problems, and they can manage data up to a very large size. And in fact, most companies in the world are absolutely fine running their databases on relational databases if they know what they're asking, they know how to ask it, and they want their answer back, because most databases are not big data. Even our big government customer says, we're managing big data of 300 million customers. Yeah, no, that's not big data. You can handle that on a relational database, and they are in Greenplum right now. And they're thinking about Greenplum. And they actually have Greenplum, and they're like, ooh, Greenplum hurts. But anyway, okay. On to graphs. Graphs. Simple graph theory is you have a set of vertices, also known as nodes, and you have a set of relations between these vertices, which are called edges in mathematics. And you have a set of algorithms based upon this graph theory that allows you to traverse from one node to another node with relations, or from one vertex to another vertex based upon an edge, very efficiently, so that you get predictable results out of a set of mathematical formula you put into your graph. What does that give? Okay, and properties is an add-on from graph databases. I'll touch on that in a bit. And you see the exclamation mark there, very good. So as a presenter, I'm going to read every single word on the PowerPoint slide, because that's what presenters do. Okay, so what does that give us? Because we have nodes and edges in a graph database and a relational database to go from one row to the next row. What is the time to go from one row to the next row in a relational database, given that you have indexed keys? It's O(n) log n. You go from one row to the very next row based upon your indexed data. Your indexed data is super fast. It's O(n) log n. To traverse a graph from one vertex to the next vertex is O in constant time. So to go from one row in your graph database to the next row in your graph database, you're going in constant time as opposed to O(n) log n, which over time, over large data sets, is an incredible payoff. Hadoop gives you that same benefit. They have an incredible indexing scheme. So Hadoop is also good for this. Big data solutions give you big data solutions. Yeah, that's a tautology. Okay, consequently, search on the next row, okay? This next bullet point is for one of my colleagues, Alex, another PhD. I love you all. Because graphs are sets, you can model everything in graphs that you can model mathematically. And since everything can be modeled in mathematics, you can model everything in graphs, even sets, so they're Alex.
That's a PhD joke.
Yeah, I know, dude. I was going to talk about ontologies and Gödel numbering and monoidal sets, but no.
But I love it though.
Okay, so Billy says meh. And why does Billy say meh? Because, you know, he looks as about as interested as you all look right now. I can actually see you. This isn't TV. Okay, so let's build a graph right now. Okay, here we go. Escape, bang.
That was a PowerPoint, no? You said there's no PowerPoint.
Yeah, so I lied. You know, I'm a constant liar. And actually, this is not PowerPoint. This is Keynote. So no PowerPoint.
I apologize. I'm taking my
So I didn't lie.
You didn't.
I just massaged the truth so much.
Oh,
Yeah,
I
gross. Okay. So you can see this better than I can see this. Okay. All right. So let's create a graph database by destroying my old graph database. Neo for J. Yeah, it helps if I know how to use it. And then tar. Neo4j cipher language, which is the language that is going to an open standard, like every other blessed thing in the world is going to an open standard. Cheat sheet. So cipher is a pretty easy language. If you know SQL already, most of you all do. Cipher is kind of like that a little bit. And here's a cheat sheet for you to help you through that. And there'll be links at the end. So let's go to Neo4j is a graph database, and it comes with.
Are you connecting locally? You have this?
Connecting locally. Yeah, thank you, Enrique, for asking.
Sure.
The internet connectivity on Wi-Fi is just terrible here. So I was going to show you on GrapheneDB how easy it is to set up a data as a service and blah, blah, blah. But it would just trash the demo if I tried to.
Just for marketing purposes, that's not provided by NCI, it's provided by Verizon Files.
So if we examine, are you all familiar with Neo4j? Have you touched Neo4j? Who is this first time that you're looking at Neo4j? So about half of you all, so great. That's wonderful. That's fine. So I do this with my new customers. I show them how to use Neo4j, and then I say, here.
Can you guys actually see and read? Or do you think that you can actually increase a little bit and zoom in? You know, especially here on the back seats.
That will help.
Can you do a little zoom in? Just a little. Sorry.
No, it doesn't matter.
No, it doesn't matter? Okay.
Yeah.
People don't have to read.
So what I want to just show you here is that there's nothing in the graph database right now. So if I go here and I select any labels, I cannot. If I want to match using the Cipher query language, any node in the graph database, and I return it, I get no results returned. So empty graph database. So we have So what I'm building here is a graph database of, and so I will expand that for you, George.
Oh, not for me, I'm fine.
No, it's
Thank you.
It's for you, buddy.
Just for you.
Oh,
Just for you now. No, it's all about you.
Alright, thank you.
Okay, so what we're going to be doing is building a graph database of amino acids. They're nucleotide triples because I'm interested in gene sequencing because I'm really geeked out. Okay, so here is the definition of the codons of amino acids to their triples. You see in the graph database there's nothing there for it. I wrote a little program that generates a sparse matrix of this, and then you just simply convert that into JSON using the Cipher query language, and then you can upload that to your graph database. And let me expand this so that even I can read it too.
Aha. So just me.
So I'm using you as a scapegoat, George, but it actually is not just you.
Okay. Feel better.
There you go. Okay, so if this were Graphene DB or data as a service on the web, data as a service on the cloud, then you can simply upload to your graph database. So the steps are exactly the same. If you have Neo4j locally running on your laptop versus if you have your data as a service running on Amazon Web Service or on Azure. The same steps involved. You curl it to your graph database, and I have the JSON created already. Wait a minute, my graph database is running. The gremlins.
You had an earlier thing. You were when you logged in. It was red text like it was a wrong password.
Username and password.
Okay, so this is very easily solved, as opposed to me debugging on the fly. Let's stop this instance, and let's remove this. Oh, shoot. You know how you practice beforehand and all that stuff? And then all that. And then let's start the database again.
What do you call that? That's the risk of a live show. Even if you practice stuff. But we know that you're not making that, man. It's not. It's real stuff.
Cool. Okay, so let's try again. And then,
Make sure you type it right now.
yes, sir. Okay. And then let's try this curl again. Oh, bang. So this is the kind of response you get from your call command. The most important thing for me to see, so I'm not asking for data back from the graph database. That's something that you can do via curl or via any REST client. What's important here is errors is the empty set. So it shows that we have no errors in the curl command that I sent. This is kind of advanced Neo4j stuff, so I'm just going to skip over it blithely. And then when we refresh our web client, we see that we now have a set of node labels, including acid, amino acids, and triples. And so we have a set of amino acids that we define, which are the set of amino acids that are, for DNA. And then let me make this a little bit bigger. As I expand G and A and T and C, I can spell the word Gattaca now using DNA triples. And you have a graph database. What am I showing you here? One, that we can start from a very simple point in our search. Two, we can expand from to the next nodes to see what is the next step out. Three, if I'm interested in exploring a particular subset of the graph, I can explore that and focus my interest on that only, as opposed to a spreadsheet where I get to see everything. So most data analytics involves looking at a spreadsheet. Oh yeah, that's great, thanks. And the spreadsheet usually is thousands or millions of rows where you're lost in the sea of data. By using a graph database, you can focus in on what you want to focus in on. And when you're exploring the area that you are interested in, the graph database also shows you related things localized to that area of interest, so you actually discover patterns near what you're looking for. So you discover localized patterns very easily in a graph database. That's my soapbox presentation. You're welcome. Okay, so we just built a graph database of the amino acid codon table right now, and it's up there on the web. And it's actually in one of the links so that you can go and explore amino acids if you want to go do that. I also have other graph databases available, which I'll share with you in a minute. So, very graphic. Meh. Okay, we just did that. Oh, and it's very acidy too. Okay. I'm not going to explain that term because it's in the links. Okay, so there's a graph. And then, how do you build a web application out of this? Now, there's several blog entries. Whoa. There's several blog entries out there saying you can build your web application from a graph database, and it's easy as 1, 2, 3. And they say 1, 2, 3, and they explain their steps using R or using Python or using whatever. But these blog entries are leaving out vital points insofar as when I went to develop the same thing, I got stuck for about 2 months. George helped me out by building a front-end JavaScript that modeled from Linkurious, a set of graph data. And then we worked with our customer, and they built the middle tier, and they were using PHP. So we built from our graphene database, which over Amazon Web Services, which was hosting a Neo4j graph database, we used PHP as the middle tier, and then we used the help from the Linkurious folks to output graphs to our customers who are working in a political environment, so that they saw relationships on their front end. So what they had before was a web application where they were actually looking at their people of influence and the people who made the decisions, and they just had one page per person. They had no way to relate one to the other on their web interface. We built them a graph database from their relational data set, put it all into a graph database, and then they were able to explore, because I said, okay, you see this, you see this, you see this, and then I handed the laptop over to them, and then they started exploring on their own, and they built the middle tier. We helped them with the front end Linkurious thing, and then they had integrated into their web application a graph database that they could see on their front end. Not something that's happening in industry right now. So I told our customer, DCI, you are on the forefront of doing this stuff, because there's blog posts about how they're doing it in hobby environments with their own little custom code. This is actually in industry. So you can do this. Not from the slide, because this is a slide of a bunch of components, and you have to to throw in the duct tape to make it work. But you can start exploring the graph database. If you know a middle tier language like Java or PHP or Node.js or whatever you're using for your middle tier, you can build the middle tier. The Neo4j site has, I believe it's chapter 21 of the reference manual of how to, yes, I do know the chapter, of how to talk via REST to their graph database, because Neo4j is not giving you just a graph database. They're giving you a graph database web service. So you can put on your laptop the open source version of Neo4j, and it comes built in with a web service already. You can build a REST client to pull queries out of that graph data. You can use the client-based apply on the web interface, which you saw a few minutes ago. Or you can build a REST client and start pulling data out and representing it the way you want to, either with D3.js or with link queries or whatever. There's several different options.
I understand all of the other related ones. How the Graphene DB, is it the same capabilities of Neo4j or that complement?
Thank you for holding your question to the end.
Sorry.
Somebody always demonstrates this for me. Yes, and we'll get to that at the end.
Sorry. Okay.
I love you, man. Okay, so building, get back there. So building a web application, after having experience of doing it, is pretty simple. The blog entries out there on how to build a web application are confusing as all get out. So what I would highly recommend to you to do is have a front-end developer, have a middle tier person, and have a graph database person. You can be all three of them at once and do it yourself, because it's really easier to do than the blog entries trying to explain it to you how to do. Really. Thanks, Doug, for building our confidence like that. Okay. Yes, but what are graphs good for? Now we'll go over to examples in industry that we are doing right now. Social media, of course. LinkedIn has a graph database. Facebook has a graph database. Twitter has a graph database. DCI now has a graph database. And they are a social network of people who make decisions in politics and people who influence those decision makers. So they have a very specialized graph database. They have 2,000 to 3,000 different nodes and different interrelations. So it's a start of graph database. They have access to 500,000 entities. So they're trying out the graph database, but they actually have it for internal use right now. Social media has this thing called, from theory, called triadic closure. And so if you're interested in triadic closure, which I am, you can do the research on it, and you can do things like predictive analytics, like taking alliances of countries and predicting World War I is one example. They were able to show the alliances after the Napoleonic Wars, and then using triadic closure without any historical reference, they were able to show how Europe evolved into the two competing alliances that led directly into World War I. Fascinating stuff for a data scientist. The markets. Now, the markets are huge. So what you can use graph databases for is to simplify the market problem domains that you're interested in. So, and this is one of the advantages of graph databases. One, you can drown yourself in information like you can with anything else. The other one is that you can focus in on the areas of your interest and then look for interesting patterns there to run analytics on the areas that are interesting to you. And that's all I'm going to say about that. Search and fraud detection. Fraud detection is the poster child of graph databases right now, because a lot of people are having good success with fraud detection with graph databases, including one credit card company that I was talking with in the Graph Connect 2015 in San Francisco. But there are other insurance and network security companies that are using graph databases now to do fraud detection. Why? Because when you have an area of interest, you know that this particular node is fraudulent, then by using graphs and appropriate data analytics to funnel in like with like, you see others that are related so that you can narrow your focus in onto what's interesting and eliminate the 99% that isn't. And that's a very powerful thing that you get with data analytics and you can do with clustering. Graphs allow you to traverse the graph and then to focus in only on the things, areas of interest, as opposed to clustering, which shows you the whole pie, and then you can focus in on the particular hot colors there. A project that we did at NCI here is we had our major government customer. They were in big trouble with project delivery. And the problem was they had so many requirements in the spreadsheet that they didn't know if they had to eliminate some of the non-essential requirements. But how do you know what a non-essential requirement is in a spreadsheet? Because every requirement looks like every other requirement when it's in a spreadsheet. So what we did was we put their requirements into a graph database, and we were able to show that this requirement was a hell of a lot bigger than this requirement here. But not only with that, but we were able to, and this is for me very important as a data scientist, is to tell a story with data. Because you've got the data. Who cares? But if you're telling a story with your data, then you have attention of the people who make decisions on the data. And so what we did was, we then did not change the graph database at all. We added to it a set of things called categories. And so we were able to group these requirements by category, so you could focus in on a category, and by focusing on a category, you could focus in on epic proportions of stories, or you could focus in on a line of requirements that gave you, if you cut out this here, you cut out the rest. Or if you cut out this, then you're affecting this category here, and that's vital to your mission. And so we were able to then go back to our customer and tell them a story about their data so that they can make decisions on what requirements were important and which were not, and make them informed decisions, as whereas before they had a spreadsheet. Businesses are run on spreadsheets, by the way. I mean, all of them, big time. Okay, another thing that we did, which George mentioned at the very beginning, was LRA, link return analysis, which is a technical term meaning there is a relationship between this thing and that thing. Again, the relational database problem is that they don't even have, ladies and gentlemen, they don't even have this. If they had this, they would be light years ahead of where they have what they have right now. What they have is a set of rows. And the set of rows have a set of factors. They call them
Clusters.
Thank you, pre-clusters. They call them pre-clusters because they can't call them clusters. But the pre-clusters are a set of at least 5 different attributes in 5 different dimensions. So if you're looking at the data in the spreadsheet, you have 5 different dimensions. You can see some are large and some are not large. So what I did was I clustered, they're pre-clustered, and I got this, which was I gave heat to each return based upon these 5 attributes. And I put that into this. The problem with this here is that you see the good with the bad all mixed up together. And so I ran it through a and actually Han Lin was one who suggested the K-means algorithm. So I ran it through the K-means algorithm, and I was able to show, to create a set of different size clusters. They had, for this data set, they had 132 clusters. How do you make decisions on 132 clusters? This is only 3,000 data points. It's a subset of the 424,000 data points they actually have in their database. And for those 424,000 data points, they have 1,332 clusters. So, if you're making a decision based upon this cluster here, what do you do? Because your decision factors is 1,332 dimensionality and size. What I did was I tried 5 clusters, that was too small. I tried 50 clusters, that was too large, and then I tried 10 clusters. With 10 clusters, I was able to say, this, and this are not very interesting at all because they're all very common. But this one right here is hot, very hot. And so we were able to focus in on 24 data points of the 3,000 data points that said, interesting. Focusing in on 24 for returns is a lot different than focusing in on 3,000. So this is a combination of data analytics, clustering, and graphing. Because with the graphing, you don't have to look at these. I expanded them out so that you could see, oh yeah, large clusters, but we don't care. But you don't even have to expand those out. You can just expand the clusters that are interesting, and then you can expand here and start looking at the areas of interest. Bam, you've got it narrowed down to green is very interesting. Black, not so much. Red is a little bit interesting, but we know here we have some interest around here. Let's focus in on the really hot ones first. This was not delivered to the customer. This was a prototypal thing I did that based upon George's, we want to look at return analysis. So I built something up to show internally. We haven't shown this to our customer. So that's my caveat right there. But this is so neat. I was able to go to GraphConnect conference, and I was able to show this to the people who are working at Neo4j, and I say, I need this because I don't have this. I do not have, and I was talking with I was talking to Jean from Linkurius, who was also there. I said, Jean, can I color clusters by data values? And he said, yes. Can I color them by multiple data values? No. So I'm able to, by building this prototype, talk to the people who are driving this technology, because I can show them a working prototype of what I need to be able to give to my customers what they need. Cool stuff. Cool stuff for me.
Can I just add one thing? What actually we're right now working on is to geomap that is going to give it an additional dimension to that, which is going to be actually is really invaluable, because now it's no longer just focusing on the problem, but you also know geographically, oh, look at this, they're also connected.
Yeah, and I don't, thank you, George. I don't have that slide, but this is another, so another introductory point before all this was that graph databases are at a point now that Java was at a point in 1995. And that was, it's really neat, it's really cool, and you've got to be kind of an expert to be able to use it. So one of the problems that graph databases have is that Tableau and other data visualization tools don't have a good way to represent graphs. And so now Tableau is working with the Neo4j people to be able to represent graphs inside Tableau. We built, internally, a prototype of connecting Tableau to Neo4j, and that we had a map of the United States, and we had a set of businesses that were related by contracts. And were they cross-state, were they intrastate? Very interesting stuff. There are 2 million small businesses in the United States of employees less than 500 people. What are the relationships between these companies? Are there circle relationships going on? You can explore that in graphs. You can't explore that in Tableau. Tableau and Neo4j are working on getting to this point right now like this. So if you have data visualization with geo information, you want to map that into Tableau or into another data visualizer. You don't have a good way now of doing that. Unless you have the expertise of building a web service, so we built a web service that communicated between Tableau and Neo4j as a web service. So we had a web service, Neo4j, we had our own web services that translated Tableau queries into Neo4j Cypher, and then translated the Neo4j Cypher data back into forms that Tableau could read. That was a lot of grunt work. It took us a few weeks to put together a pre-prototype. that we haven't yet shown to our customer, and so it's not a slide. So clustering, and then yay, we're done. Okay, settling. What time is it, Joe? It's 9:30. Oh my gosh. Okay, so set of links. Okay, so what is a graph? You can read all this stuff. Oh, one thing I didn't cover was the regressive imagery dictionary. So a lot of interesting work is going on around document processing, meaning you have a set of documents. You know kind of what they say or you don't know what they say. What do they say? The regressive imagery dictionary categorizes documents by primary, secondary, and emotive categories. And then you can use those to classify your document on how it feels and what it says, and then you get a set of attributes that give you dimensions upon that document, and then you can map that document to related documents without reading the documents. And so you can start putting documents into piles that are interesting and not interesting for you. The regressive imagery dictionary, there's an open source version of it available. I took that thing and I put it into a graph database, which is available on the web right now. So if you have a connection that you can say, give me, you parse your document into a set of words, you put them through the regressive imagery dictionary, you have a set of indicators, and you have a graph on it. Coolness. Yay, we're done. And so the links, anything else that I missed? Okay, graphingdb.com. If you stay afterwards, Hanlin has a code to GraphingDB that allows you, so you can go to graphingdb.com and you can, which is a data as a service graph database. And you can start using it for free. It's up to 1,000 nodes and 10,000 relationships, which is good for some graph databases. The RID, the Regressive Imagery Dictionary, does not fit because there's 3,000 root words in that. The code allows you access to the next level, which is the development tier, which I believe is like 100,000 nodes and 100,000 nodes and 1 million relationships, which is good for most graph databases that you have out there. It doesn't have daily backup schedules, which was vital for me because I wrecked my graph database one time and I had to revert to the graph database before I did the wreckage, which was 2 days ago. And so I actually have the professional edition, which at the lowest tier is $50 a month. I'm not representing GraphingDB, but they are sponsoring this session right here, and that's why you're getting the code for them to try them out. They're one of the available vendors. I recommend you try them out. They have distributions both on Amazon Web Service and on Azure. And what we actually did with our customer, DCI, is we were going to they have an Amazon Web Service set of Amazon Web Services. We were going to put Neo4j as an Amazon Web Service for them. But security, installation, maintenance, all that stuff, GraphingDB takes care of already. I said, here, get the $10 edition, try it out. And so they were able to put their entire network in a graph database for $10 a month. And secure and all that other stuff. Yeah, so I don't have to worry about security. Okay, amino acid, we built that here in this session here, and there's the links to that as well. The link to this presentation is not on the links here. So I'm gonna have to provide that in the Meetup information. But so that'll go on tonight, the link to this presentation, so that you can look through the slide. And it also has interesting commentary on the slide by me. And is that it? Is that the last slide? No! Bye now. Bye-bye.
Thank you.
Did it answer your question? Did I answer your question already? See, it was in the slides already, and you were like asking a question, and it's like, I swear. So Now, labels are a way of, you're gonna love this answer. Labels are a way of labeling things, and properties are a way of giving properties to things. So let me explain. Let's call this up. So, and this is relevant to your business and to our business with DCI. And the relevancy is this. So after my non-explanation, let's get into a real explanation. I unplug myself. That's beautiful. So you're seeing this slide wonderfully. You're welcome. I'm not panicking. I'm so panicking. Okay. Here we go. So you don't see any labels here. But the labels are here.
Right.
Yeah. And the labels are, what is this thing? So it's the Duns Scotus problem. And one is the hasidity versus the quiddity. So what kind of thing is this is a label. And that is, are these persons influencers or are they decision makers?
So they're basically subclasses of a node. If you were looking at it from like an object-oriented sort of thing, you might have committees, individuals, and vendors.
Yeah, and those are the labels. Now, properties is what got our customer really excited, and that is, they said, when these influencers here are influencing Mike, the influence is not 100% every time. I'm giving Mike $1,000, but that does not mean Mike is going to vote for my decision based upon the gaming campaign. Mike might actually vote a different way because he's got a bunch of different influencers, each having a bunch of different weights. How do we represent that in the graph database? And you don't see this here because it's not on the
Right.
label.
So a label, the label would be pays, but the property might be amount.
Property might be amount
Or date.
or date or percentage influenced based upon calculation.
So they're roughly dimensions versus metrics?
And man, can you come up here and do the presentation?
No.
Yes, yes. So with labels, you are defining a thing as a thing. You're giving it its quiddity. With the properties, you're saying, you can say a bunch of different things, but you're giving it specificity. So you're saying, this is an influencer label, but the influencer's ID, since we're not sharing that with you, is 297. So that's specific to this particular node. That's very specific. But the influence here, which you do not see, is 72%. And that's a property.
Can a node have multiple labels?
Yes. And inside Neo4j, yes. And I tried that. I'm kind of like a monomorphic kind of guy.
So you would run that as, so in essence, committee, type committee, party would be, you would put party as a property rather than making it a dual committee, Republican committee, Democrat.
Actually, no. I would act, and this is what our customer has, is that I would create an entirely new node called committee,
Right.
and I'd create a set of nodes around that committee with the specific subcommittee names. And then the person would belong to multiple subcommittees, so you can have multiple relationships coming from a label. And so the problem with a label is once you label a node, you're stuck with it. And if you have multiple labels on a node, then how do you determine what is the role of that person in that particular instance? And this becomes vital for us with campaigns because the decision maker has different behaviors in different campaigns. And the influencers have different influence on the decision makers based upon the campaign. So very, very specific. If you're talking about abortion, or you're talking about gaming, or you're talking about gun rights, it's all very different campaigns. And if you put a label on that, then you are stuck with that attribute, or you're stuck with that label actually,
Right.
For the particular node. But if you create a set of nodes around your different aspects, and you create the relationships, then you can control the intensity through labels on the relationships, which is a very powerful thing that is not explored in graph theory, and graph databases have just started doing that. Properties are new as of 2, I believe, for relationships. And that's what we're exploring, and that's what our customers are very interested in. So what Tim was asking was, okay, the difference between labels and properties. Labels are ways of giving a classification to a bunch of things, and properties are giving specificity to each thing. Now, a thing is a technical term in graph databases. Things can be either nodes or relationships. And you can search against labels, you can search against properties, and you can generify the search to, you can search based on relationships. So you can say, give me all the relationships in gaming, and it'll come up with this graph. Or you can say, give me all the relationships to Michael, which is a node, not a label, and that is a property on this particular node that's labeled as decision maker. And then boom, for Michael only, because you're doing the search based upon the property of that node. Thank you.
By the way, just to also add one thing, he just gave you one aspect of using the graph databases, manually researching, and discovering stuff. There's another whole other universe of what he mentioned, that mentioned at the beginning, that SQL-like language that you can actually write expressions. And believe it or not, one of our customers today, they have the approximately of 2,000 lines of Java code to achieve what we can write here with a 3-line query. For instance, discover related companies that probably are using for tax evasion. There's certain things that you can write a 3-line query, and probably that might actually work in another meeting where we can actually do a demo on the the language. And people can say, hey, how can we ask this question? So we'll write that.
Yeah, something on Cypher would be great, because
Yeah.
there's very little on Neo4j. It's a very bare bones.
And their advanced Cypher course.
No, this is not meant to really.
No.
Cypher
Yeah,
course.
but I mean, what Tim is pointing out here is that there is a dearth of information and knowledge out there about Cypher. If you want to use it with any depth, you are going to be at the forefront of using Cypher, because the Cypher courses they're teaching right now are basic retrieval, matching queries in Cypher.
What in reality some of the most fascinating ones I would like to run is I'd like to run negative, lack of relationship. I have a node. What are the nodes that have no relationships?
Yeah.
Because
And you can do that in Neo4j 2.3 now.
That's
Yeah.
good. That's a very good application of Neo4j.
I'm done talking now.
No, well, and another interesting thing that we're interested in is, which George alluded to, was circular relationships. And those show up and we did a demo based upon that, where company A is paying company B, is paying company C, is paying company A. And you can very clearly see that in a graph database. It's visually presented to you.
You can do it manually.
And you can do it
Yeah,
manually.
right. Or you can write a query and extract it. That's what I meant. There's an automated and manual way. And like like you're saying, the idea is first reduce, and then you can have the final verification inspection by human by visually seeing the stuff.
And we did do that. We
Yes.
presented internally where we showed this,